linear regression simulations webpage. So I added hypothesis testing and confidence intervals. So first we can start with our data generation. So you can start with a sample size of 50, a mean of 0, variance of 1, intercept of 2, slope of 1.5, and 50 simulations. So after clicking generate data, you can see we have two visualizations. So the first one is a scatter plot that shows our original data points in blue and the fitted regression line in red. And the second plot shows the histograms of our simulated slopes in blue and the intercepts in orange, and their respective observed values can be seen with the dashed lines. Now, for hypothesis testing, we can look at our slope parameter and test greater than. So this tests whether our true slope is greater than the estimated value. And our p-value represents the proportion of the simulated slopes that are more extreme than our observed value. So if this p-value is less than 0.05, then we have evidence that the true slope is confirmed greater than our estimate. So, and here's the histogram. It shows where our observed value, which is the red line, falls relative to the hypothesized value, which is the green line. And this helps visualize how extreme our result is. Now we can look at confidence interval. So we can select slope as our parameter. Start with 90% confidence. So we get an interval of values, and the gray points you can see show the individual estimates from our simulations, and the horizontal band shows our confidence interval bounds. So the mean estimate is shown by the horizontal dark blue line, and the true parameter value is marked by the red dashed line. So something I observed is that the histogram distributions help us understand the uncertainty in our estimates, and our simulation approach, it lets us see how often we capture the true parameter values. And I noticed that the p-values, they align well with what we see visually in the distributions. So this approach gives us basically a practical way to understand the uncertainty in our regression parameters, and lets us make statistical inferences without relying on assumptions.